Okay, so in the previous video we just looked at how all of this stuff fits together, and after sleeping on it, I did get some inspiration about how it should fit together. There are two main options, I think, and I'll briefly explain them. Option number one is to be intimately aware of the server processes, and to doing a rolling restart by basically, if we have 8 processes hosting the web application, to basically like restart them one at a time. So firstly, you take one process that's currently running, tell it to stop accepting connections, wait for it to drain, stop accepting connections, then start a new process to replace it with the new application code or whatever. Then that would, once that was accepting connections, you would kill the old process, or gracefully wait for it to stop, or wait for a while and then kill it. And you do that 8 times for all 8 processes. That approach isn't too bad, but the problem I have with that is that you need to be intimately aware of the structure of all the processes to do that. And async container, while it does have some level of awareness of when you've said, okay, start 8 of these things, or start 1 of these things. So in theory, like we could know that. I've thought about the other option is basically to think about containers as atomic units of web applications, or functionality. And so if we have a container which is running, which contains multiple application servers, in order to reload that application, we can create a new container, and once that container is created, then we can shut down the old container, and then sort of in theory it's been replaced. And the interesting thing about that approach, there's 2 trade-offs. So firstly, with a rolling restart, the most memory you'll ever use is 1 extra process. So if you have 8 application servers, you need to spin up 1 extra one before you can shut one down. And so if they were using like 200 megabytes of memory each, then at most you just will be using 1 process more of memory. Whereas restarting the whole container will require like twice as much memory. But it's a bit of a trade-off, because the value in restarting the whole container is that if the container fails to come up, then you don't shut down the old container. You just kill the new container. So if you spun up a new container and there was a syntax error in the code that you deployed or something, and bundle exec Falcon didn't like start up because config.ru had a problem or something, then the old container would still be working and you wouldn't have to kill it. So things would keep on working. With the rolling restart, I guess you can do the same thing, but it's a little bit more tricky, because with the Falcon host, you can spin up multiple application servers, or even just arbitrary servers, whatever you want. And so you wouldn't necessarily know until the whole container is like finished initializing that some part of it had failed. So if you were incrementally like restarting process, you might restart like half of them and then get to another one and suddenly something blows up. And so you have like half of the new processes and half of the old processes, and it just seems like a bit of a disaster to me. So I've sort of been thinking, okay, so there's 2 approaches. We could do like a rolling restart, process by process, or we could just think about containers containing application servers as kind of atomic units, and either they're running, they're not, they're failed, they're not. And to do a graceful restart, we essentially manipulate the state of the current container and make a new container to replace it. And once we are happy that the new container is ready to go, then we can shut down the previous container. The one caveat on that is when we... What was I going to say? It's going for it. We'll come back eventually. There are a couple of like caveats though. Right. The most important one is that when we spin up the new container, it has to be able to run simultaneously with the old container until the old container is shut down. What that means is, in the case of Falcon, when Falcon is running in the Falcon virtual mode, it uses a Unix socket on the file system, and that is used for accepting connections. And so if you spin up like 8 processes, they all bind and accept connections from that Unix socket. When you spin up like your new container with new processes, they also listen on the same socket. And so if you were to spin up a process that could only exist one at a time, so like if you have the old container and the new container and that is somehow colliding, then and they're not able to like run simultaneously until one is shut down, then you'll have issues. But I think for the most part, that's a acceptable trade-off. So what I've been trying to do is I've been trying to isolate this code change to async container because I want to solve the problem in here so that in theory, if anyone uses async container to spin up multiple application servers, it could be like DNS, it could be HTTP, it could be like whatever, that they just get basically graceful restarting as part of that. So my goal is to kind of just change async container to make it possible. If you write your code in the right, if you build your server using async container, then it will be scalable across multiple CPUs and you will get graceful restarting for free, basically. So yesterday I was thinking about how this should fit together, and we kind of had a look at how to gracefully shut down an async reactor by using SIGINT. And that worked, and I guess we got to this point where I just wasn't really sure, I hadn't really formalized in my head the different approaches to take, and just going through the code and sleeping on it gave me kind of some ideas to think about. So this morning I started implementing async container controller. Now this existed previously, it was just a base class for the forked and threaded containers, but I've changed that. The code that was previously in controller I've now just called generic, so there's container generic, and forked and threaded both inherit from generic. And controller is now something which manages the life cycle of a container. So when you make a controller, what you do is you pass it a block of code which is used to create the container. I'm still trying to work out the semantics of how that should fit together, but ideally the user code doesn't know whether the container is forked or threaded or hybrid or some other design. The user shouldn't have to be concerned with how the scalability or how their software is applied to multiple CPU cores, in my opinion. So controller tries to isolate that. And so this constructor, I've got a simple example which I've been playing around with. This is just examples container.rv. So what we do is make a controller, and the controller, we pass it in a block, and this block is responsible for starting all the children processes. And so in theory, if you run this multiple times, you end up with multiple containers which are atomic units of child processes or functional application servers or whatever. This one is remarkably simple. We just tell the container to run 8 times this block of code and to restart it if it blows up, if it fails. And this code has a loop which it sleeps for 1 second, and then it I guess that's 1% of the time it will fail. So every 1 second there's a 1% chance that the child processor will blow up. And if you have, in this case, 8 processes, that means it's more 10% chance every second at least one process will. But it's just kind of simulating failure. Finally, we have this controller loop down here. I've put quite a lot of logging in just to try and capture the flow so I can see how it's all fitting together. So when you call controller.run, and this is actually, I don't think it's completely working at the moment because I think I just changed something, but and some of this stuff is now redundant as well, but who cares? So we call self.restart, and what self.restart does, the first time it does it, there's no previous container to stop, so it just does it just starts it. I mean, I could make a separate method, but there's no point. So what it does is it calls the constructor with a container. I've just hard-coded the fork container for now, and if that container has failed, so what that means is a process that was spawned or whatever, what have you, has essentially exited with a non-zero exit status. Then we call container to stop to kill everything in it, and we raise the container failed exception. Now I'm not completely certain that's the right behavior. in general, but like at least for now, like it's okay. So this is kind of like, okay, we couldn't start up. And then finally, if we get to this point, we know the container is kind of good, like it hasn't like completely blown up. Now there's every chance putting in here like 10 seconds, like wait for things to like warm up a little bit before we check if anything has failed. I'm not quite sure if I'm going to do that yet or not. It might be a configuration option in the controller. Obviously, this is all running in parallel. So if you spin up a process and that process takes 3 seconds to load your application code and then finally blows up because there's a missing symbol or something, like this will take a little while for that process to exit. But anyway, then we come down here and we call container.wait, and what all that does is it basically waits for the container to finish executing. And I still haven't quite figured out the semantics of that either, but in essence, the point of this is to basically go, okay, just wait until the processing is finished. Now, in theory, like containers don't have to only contain sort of application servers that run forever. You can put you could use a container for a job server, for example. You could feed just one-off applications into it, or one-off you could spawn jobs into it, and it was kind of designed that way. So I'm not quite sure. I need to write some specs probably to see how that interacts, but essentially we wait for the servers to finish, die, or whatever, and then if the user sends like a signal to this process, then this will actually exit with an exception. This is new to me. I've never used signal exception before, but in Ruby, it seems like I did like a little test, like with 10 threads. I don't quite know if this is just because of luck or if this is documented to work this way. I probably need to read a bit more about it, but so we make 10 threads and those 10 threads just sleep. Then we have the main thread which just calls join on all those threads and exit 0. And if we run that, and then we go curl 46319. So we got the output was join sighup, and that happened from that line there. None of the threads got that signal, only the main thread got it. And so maybe that's a problem if you ran this code on a separate thread. I don't quite know where the signal would end up, but at least for now, like that's sufficient for my needs. So because the concern would be that the signal would come out of this thread that's sleeping, or like one of those threads would just randomly pick it up, which would be kind of annoying because I'd have to somehow funnel that back out. Right, so in this controller run method, when we get a signal exception, so I did a little bit of reading. It turns out sighup is often used for reloading configuration or reloading child processes. So if we got the sig hang up, we call self.restart, and if it failed, then we log the failure and we just continue on like business as usual. That's like the magic, the secret sauce, where if the new container didn't come up, the old container just keeps on running, in theory. There's every chance that the old container gets balked as well for some reason, but that's handled by the container itself. The container will restart processes if they die. I guess in theory, if you load new code into your application server and that code is bad and your processes are crashing, when they are restarted, they'll load the new code and crash because of the code is walked. So like, at the end of the day, like you can't solve every single problem. And maybe there's value in trying to detect some scenarios like that, because otherwise you can end up in a situation where async container, you load your code and it immediately crashes, and async container goes, oh well, I'm going to restart that process, and there's no back off or delay or anything like that, so you can just restarting processes over and over and over again, which probably isn't that great for your application server or CPU. Right, so what I'm going to do is, this was working, but something I did stopped it from working just a few minutes ago. So I'm going to go ahead and see if we can, I can't kill it anymore. 4, 6, the impossible to kill process. Okay, great, it's gone. Okay, so is that loading that? Yeah, it is. So what have I done that stopped it from working? So this running is no longer necessary. The key point for me is kind of just getting all the invariants right. And sometimes that part's tricky. So we've started up the container and it has 8 child processes, and occasionally those child processes are dying and being restarted. A 1% chance over 8 processes once per second. And so that's just to kind of make things interesting. Then if we look at the parent process 46589, now this exited last time I tried it, and I don't know why. It shouldn't have. This should trigger this code path, but it didn't. What have I changed in the last 10 minutes? Oh, my undo buffer is empty. Okay, for a start, let's just stop dying randomly because it's kind of annoying for debugging. Let's make sure I'm getting the right process. 4, 6, yeah, it was the right one. Okay, so let's have a look at where it's going in here. Did I just add that line? So it got reloading container, which means it got there. Setting up container dot wait. Four, 6, 7, 7, 4 was exiting. That's okay. That should be one of the previous ones. 4, 6, 7, 7, 4. Yeah, it was. Debugging this stuff is always tons of fun. Let's just take it back to one process. Setting up container. Child process started, but then it was immediately interrupted. Why did it get interrupted? Actually, yesterday when I talked about how this was all structured, I mentioned another gem called process group, and while I did used to use that gem in async container, because that gem was slightly different in terms of what it was designed to do, which is queuing up and running processes on a limited number of CPU cores, I actually realized I took all the core parts of it that I wanted and put it into this class here called group. So there's actually, I'm not using process group in the async container, but I have a different implementation that suits the container model a bit better. I'm calling stop somewhere and I think it's hitting the wrong container. I think I know what's happening. I took the loop out. So it was after restarting, it was like, yeah, I've done restarting the container, and then it was just exiting and stopping. That's pretty funny. Four 716047160. Okay, great. So let's have a look at the output. So I'll just explain what happened. So I did send sig hub to the parent process, 47160. But anyway, when I first ran that, it wrote out setting up container, which meant that it executed that code there, which basically created one child process, and that process is set up to restart, and that just ran that loop, which is just to sleep forever. And then I sent sig hub, and so we came into this reloading container, and what we did was we made a new container, and then we called the constructor on that new container, and that started that caused the new process to start up, and then it didn't fail, wasn't marked as failed, and so then we called stop on the old container, which did that. Now what's interesting about this is that even though the order was that followed by that, we actually got the logging out in the other order, and that's because it took a moment for the process to start up. If we were to put, like, I don't know, like probably, actually 1 second is probably enough based on, yeah, even like 100 milliseconds would probably be enough in this case. What's interesting is that systemd actually has a daemonization mode. There's a couple of different modes, and the way that it works is systemd needs to know when your service has finished initializing and can actually do its job. So if you think about like a web server, when you start the web server, there's obviously a period of time when the web server is just like loading configuration, loading other stuff, and at some point the server binds to the sockets that it's supposed to be listening on and can start accepting connections. And systemd, before it can, if you have a web server that needs to be running before you have some other service which is accessing that web server, systemd needs to know, like, at what point are you bound and accepting connections before I can start the subsequent processes that are depending on you. And there are a couple of modes, but one of them is that systemd will fork a process, or like start your process, and then that process does all the loading and binding, and then spawns off a child process, which is the actual server that is processing requests. And then once the parent process exits, that indicates to systemd that the child process is ready to roll. So it's quite fascinating that how those life cycles are managed, because obviously you want to make sure that you indicate to the user somehow that the server is actually operational. There's definitely been situations where you restart or reload Nginx, but then something you've done deep in the guts of like PHP, FPM or something has just caused it to completely fail, and you don't know that until like a few moments after Nginx has restarted. So anyway, let's make this a little bit more exciting again. Now, if we increase this threshold, what that is going to mean is, and if we wait in here for like a little bit longer, like say 10 seconds, the chance of a process dying with X status of 1 causing fail to be true is going to be much higher. And I'm kind of interested to see if, like in that situation, I wonder if like that should be in a loop, so that if you've asked the server to restart, I guess ultimately you got to be careful about how much of this stuff you put in a loop, but I guess you have to think, okay, if you try and spin up the processes and it fails, what's the chance that trying again will be successful? And I know that some things like systemd, for example, has like a back off. So if you execute like a child process, so like you have a systemd service that's spinning up like some service, if it dies like 5 times in 10 seconds, systemd will wait 30 seconds before trying to spin up again. And that you know, like that makes sense. Although a lot of that policy driven stuff, I kind of want to avoid an async container, because I hate like configuration settings. I just think things should work out of the box with like sane defaults. So starting container setting, I wonder if that's going to blow up or not, because it's definitely the case that I kind of want to see what's going on at that point. So containers collect statistics. That seems odd. So it spawned 8 processes and there's been 0 restarts and 0 failures. But there have definitely been failures. So what's going on? Is my statistics not capturing that for some reason? So the statistics, the async container statistics basically just capture information about what's going on in the container. And I guess the logic behind that is it's kind of useful to know if I wanted to do like some kind of back off or time-based restarting process, then probably I'd put it in here, you know, not just collecting when, like how many times it was restarted, but like when it last restarted, so they could have some kind of like, okay, how long to wait until I try again, which would take all of that into consideration. But for now, this is just really simple, which is fine. And so in here, in this loop, the spawn loop, so this is what is being called container.run 8 times, is calling this, which goes 8 times async. Async is calling spawn and then making a reactor inside that. So spawn in forked is hitting this code here. And so firstly, it's hitting that statistics.spawn. So we have 8 processes, so that line gets hit 8 times. And then basically exit status equals group.fork. And so then depending on the exit status, we either have a failure. And maybe we should capture like success as well. I don't know. That would be interesting. But I don't know why, if this process is failing, it should definitely be hitting this block of code here. So I'm gonna have a look if I can capture that. But let's just make this one, because some other ones have 8 processes all blocking. It might be a bit of a nightmare. Okay, Control C is no longer working. Oh, it's funny when you make an indestructible system. Okay. Okay, so it died and it came, oh no, it stopped there. So it died and it didn't actually... I think I know what's happened. So the process has died, but we haven't actually collected the exit status. So I guess this is one of the things that I really like about fibers is that they allow you to do really fascinating. You transform, like, from the user's point of view, what is essentially linear code into non-linear code without them realizing. And so what's pretty cool is, so this process group uses fibers. It's not async. Like, it's not using async, which uses fibers. It's just using straight up fibers. And the way that it works is we spawn off a process and we get a PID back, and we call this function wait for. And wait for, ignore all of that stuff because it's just setting up the process group. This line is the critical one. Actually, all of these lines are critical, but actually those two are the most important ones. So we have a hash table of process IDs to the fiber that's currently executing. And so what we do is we have to go this PID, that fiber belongs to that PID, and then we go fiber.yield. So what you are required to do is you're required to wrap any call to spawn or fork in your own fiber. And when you call that, it will yield until the exit status is available. And then the top level fiber or process, the top level fiber, trying to avoid mixing up terms, is required to call wait. And while there are any processes running, we call wait1. And what wait1 does is it calls process.wait2. It's going to sound stupid. And it waits for any process in the process group to finish. And then it gets the process ID and the status of that process that just finished. And then it finds the fiber that was relating to that PID, and it resumes that fiber. So then that means it comes back out here and it returns the result, which means that spawn or fork returns the exit status. So you can basically run as many processes as you want, and inside this code here where you call spawn, so this is where we make our fiber, and that fiber then has the logic for restarting and managing the individual process. And the reason why I like that approach is because I can think about the logic of this. It's very straightforward. I fork the process and I get an exit status back, and then I can check that, and then I can decide like what to do. And the alternative would be trying to like manually manage that. But in this case, each fiber encapsulates, so I can call spawn as many times as I want, and then it will just capture that. And if I wanted to have like a different a different logic or a different behavior, then I could do that in a different function and it will still all work in harmony with each other. But yeah, so the problem that we just ran into is we never gave the this code here, all that does is it basically ends up calling like spawn or fork. But even if the process like dies right away, we still get a process ID back. And so we don't check, there's no check here yet. The only way that you end up checking is if someone calls wait. And so that's the interesting point. We don't know if it's failed until someone has called wait. So what I'm kind of interested in is whether we need to extend this abstraction a little bit. Okay, so it will be nice to be able to say wait, but for like 10 seconds and see if anything fails. And I think we might be able to do that. So if we provide the flag, if flags is process w no hang, it means this function will return right away if and there will be nothing in there if it's empty. So I'm not quite sure how this part should fit together, but let's just try whacking it out and see what happens. Okay, so I guess in here, rather than sleep 10, what we want is that. And what that's going to do is it's going to wait for 10 seconds for the processes to start up. And if any of them fail in that time, then this will be bumped up. And then we'll know the container has successfully started or not. So how do we implement this? The first thing we need to do is in here, we need to pass that through. Then in here, I wonder if we can just in theory, don't really like this implementation, but so we're literally going to wait 10 seconds or whatever like the duration is, and then we're just going to jump into this code. Nah, I don't necessarily want that in a loop because self.wait one flags. Let's just get rid of that. Yeah, there's not really much point using that. Hmm. So that will basically dequeue any process status, exit statuses, until there are none left. I don't really like that code very much, but maybe it will work. That seems strangely silent. I should have like blown up or something by now. What has happened? Okay, it did finally blow up. Let's just, it can just blow up every single time. But let's put the sleep one first, or it's gonna, waiting for startup. It's like it never came out of this loop. I feel like that should eventually exit with no. Let's just do it by hand and see what happens. Let's see what's happening. So self.wait1 is, it's actually resuming the fiber, and we do want to do that, or do we? Because we're just going to stop the container. Fiber and status. So if it's W no hang and there was no process status to collect, then it returns nil. Otherwise it still does the usual behavior. But what we want is we just want to try and get we want to know if it failed, and we can't actually, to be honest, like we don't know if it failed. Basically what's happening is it is coming here, then it is coming here, it will be calling that, and then it will go around in the loop and it's starting it up again. And that all happens before it comes back out of wait 1. And then wait 1 will wait for that process again. But I guess W no hang should mean that PID, but it dies right away. So basically, we end up waiting on the same process over and over and over again. If we use this form, then we don't resume the file, we won't mark it as failed, and then we don't restart the process either. So I feel like this is totally different semantics. I'm not quite sure how to I don't like functions that just have like an argument and that argument completely changes the semantics of the function. That to me is like should be two separate functions. So I'm trying to avoid like that, but it's a little bit tricky. I guess in the simplest case, that is sufficient. We'll only wait for the process, like one process to fail or not. And that's actually like enough. Because as soon as one process has failed in the container, the whole container will be restarted or thrown away. So it died, it wasn't restarted, the status should have come out there. Then, I forgot to save the file. I want to, yeah, good. I'm gonna stop there, cool. And 10 is kind of annoying, let's just make it like 2, so we have to wait forever. So the container has failed because that process died. And it did try to restart it, but it failed again. Because that's just the nature. I can't decouple that with the way it's implemented. It would be nice if that was decoupled. Maybe I'll change it. And so because the container has failed, then this whole thing is going to blow up because it could not create the container, which is exactly what I want. So here we have a magic number, which is kind of annoying, to be honest, because I don't know if there's any like logical default for that. The only, I mean, as I said with systemd, it forks a process, and once that process exits with a, I guess like with 0 status, then it assumes that any child process has spawned are ready for action. But so systemd just waits for the child process. But the container model is a little bit different, and I don't have that luxury. And I guess, in fact, in general, it's a little bit tricky because that fork model, it requires you structure your code in a very specific way, like i.e. a parent process that binds any sockets and then forks off children processes which inherit that binding, and then once those children have detached from the parent process group or whatever, then the parent exits and then systemd knows everything's ready to roll. But I don't have that luxury here because the container is a bit more flat. The container is basically just let's spawn a bunch of processes, and there's no specific logic or guarantee. I mean, you could be spawning anything into this container. In the case of Falcon, it's like bundle exec Falcon Falcon host, and it doesn't have that. It just doesn't have the same model. So the only way you can really know is to have some timeout. I guess we have to add it. Maybe I'll get some inspiration about how to deal with that more effectively. I guess it's pretty interesting though. In general, if you have a process like an application server, how do you know when it's ready to accept requests? Like, you don't actually. The only way, I guess like having a parent process and having children processes, that is actually not a bad way of doing it. But it only works in the case that you have that very specific model. I don't know, I wonder if there's like a more general approach. I mean, I guess another option would be to use like some kind of like pipe or a signal or something to tell like the parent that you're ready to go. But again, like that requires the child process to implement some specific logic. There is somewhere in here when I wrote this, I think somewhere in here I did play around with it. This is a really fascinating code. This is the code for the Unix endpoint, and the Unix endpoint is the socket, which is a file on disk. And so it's kind of interesting. It's actually pretty funny. Because of the limits of the sock address struct, you can only have a path with 104 characters. I guess, I put a note here, you could maybe change directory to deal with that. But then there's this logic here, which I think was kind of interesting. How do you know if you can bind to the socket? And this was quite tricky because... So this is when the child application server is binding to the socket that's on disk, and that was a way of figuring out if any process was actually, if you try to connect to a Unix domain socket and there is no process currently bound to it, then connect will fail. So it was kind of just interesting to figure out how to implement this one. So we can tell if someone has bound, if we can tell if there's any process which is currently bound to this endpoint, and we can connect to it, then as soon as we connect, we return true. Otherwise, we return false. And I think, I can't remember what situations like this happens. It might be when someone else, like another process, has bound to that Unix socket. So if you have like an application server and it crashes, then no one can reuse that socket on disk. And this logic isn't quite right, I don't think, because I've definitely had issues where the socket has been lying around and hasn't been cleaned up properly. But basically, if you try and connect to it and you can't, then you know that there's no process currently bound to it. And if it exists, then we should unlink it and retry binding to that address again. It's kind of interesting that you end up with these complicated things. Anyway. So, I wonder if all of this, I wonder if we're close enough to something working that we could stick it into Falcon. So the controller model is totally different from what I've done in the past. In Falcon, because async container has changed, it's been something which has really come from something very simple to something that is able to handle these complicated situations. So Falcon, so async container is like super unstable, and so actually it looks like both of those are quite unstable. So I've pinned that to the patch release. So I'm happy to make completely breaking changes in this code, but Falcon, good old Adam. Let's just have a look at this one. So Falcon Serve is very much using the container itself, and it's not using a controller to manage that container. And what I need to do is change all of this code to use a controller, an async container controller, so that if someone sends sighup, then it will basically reload the configuration. But what actually needs to happen is this entire function, which loads the configuration, and that part there, actually, that's the configuration that we want to reload. So if someone edits the config.ru and then sends sighup to the Falcon process, it actually needs to reload that configuration. Now, as I mentioned, like in the previous video, like we're going to be really careful, because if we try and if we're using multiple threads, we can't reload code like gems. So we're stuck with whatever has been loaded into the process. But that doesn't mean that Falcon Serve couldn't just make a spin off another process. But to be honest, like this, I'm okay with this, and it's the simplest implementation, and it works in both like JRuby and Truffle Ruby and MRI. You know, JVM implementations of Ruby don't support fork. Pardon me. While MRO, obviously, fork is like the preferred option. So, that all being said, this all has to change. So, we could try it. Let's see what happens. I think all the specs will be broken in here as well. I'm not really looking forward to running RSpec. Oh no, everything worked. That's a bad sign. That's a really bad sign. I expected more stuff to be broken since I've changed a lot of the semantics in this code. But anyway, you know, let's try it. There's no harm in trying it. So we'll just install that as a development version. Or actually, you know what would make more sense is to come in here and go gem async container path async container. Is it going to complain about the version? probably. That's okay. Let's make sure we've got the latest code. Then we're going to come into here and bump that. Excellent. And now we got to rewrite this. Actually, you know what? I should probably just I should probably just stick that in the main file. Okay. And I don't support specifying a container class yet, but I probably should. And there is a default for this. Container best container class. Container class. And then in here we want to use okay, right. So okay. The attachments are also probably wrong now, the way that works. So the point of attachments is in this call container.wait, which is now it's going to be controller. It's going to return the controller back out, and it's not going to be wait, it's going to be run. It's controller.run. Okay, right. The point of attachments, I think I explained this yesterday as well, but I was half asleep, so I'll explain it again if I didn't. So this code is either running in 8 processes or 8 threads, and if we call fork, I can't quite remember how this all fits together, but if we call fork, then that bound endpoint should be closed in each child process. I believe. Actually, that doesn't make sense because it is to do with managing threads and process model, and attachment. It's actually used in, well, right now it's implemented in container, but I think it's wrong. I think this needs to move into controller probably. And so you attach behavior to the container, and when you stop the container, it executes that that stuff. So like in the case of a bound endpoint, even though you have 8 processes all using that bound endpoint, once you stop them, only once does the bound endpoint get closed. But yeah, I wish I wrote documentation at the time I was thinking about why this was important. Sometimes stuff like that is just so annoying. At the time it was like so obvious why it was necessary, and now I'm struggling to explain why it's necessary. It kind of sucks. Anyway. Oh yeah, we're going to inject container class. Container class is... Okay, anyway. I'm sure it will become apparent why it's necessary, because controller. Make that a bit more obvious. Okay, right, so we're running Falcon server restart, container options. I sometimes get people telling me, why do I put self dot something in front of these? And it's just because when you have really dense code, sometimes it's nice to know that this just isn't some random local variable. It's just clearer what it's actually doing. I get it, like sometimes it's nice to you're by adding self dot you're removing a layer of indirection, because you're being explicit about the target of or what that thing is, because that no longer can be. Before it could be a local variable, or it could have been an instance method, but now I've made sure it's only ever going to be an instance method, and it can't be private either. Some people would say that's a bit silly, but I don't know. Anyway, so we made the container. Container's going to spawn up into the Falcon server, and that's just going to run. And I guess what I will need to do at some point is figure out that whole Graceful shutdown process will have to be stuck in here somehow. But that's okay for now. Yeah, honestly, I don't know if it's going to work or not. I feel like that's all I need to do, but that doesn't seem like I've done enough. So this is not a graceful restart, because it's still gonna, and it's gonna send into all the child processes, but it will, in theory, reload the config. Oh yeah, great. So that seemed to work. That's awesome. So it did reload the config. But as you can see, it was reloading into the same process, so the constant was redefined. So what I want to see is that if I come into this example, and let's see if I just stuff it up like, and do that, and then I try and reload it. Okay, so it just completely crashed. And why was that? I think I know why. what's interesting about the position of this line and the implications of it are quite complicated. When this line is outside of the controller block, it will happen once, and the application code, configuration, will never be reloaded. And if you fork 8 servers instances, they will all share any code that was loaded by the application. And for development mode, that's probably what you want, to be honest, because in development mode, I guess it's better to have I guess there's different ways you can think about it, but ideally your application starts up quickly and you can throw them away and restart them as needed. When you move this into here, that means every instance, so every child process will have to parse and load that file. And so the copy and write mechanism for sharing code and data structures is never going to be as efficient. If you have this in the outer, outside of the individual process, then it will be done once, and then the memory will be shared between those 8 instances. But if you put it inside the instance itself, it will do it 8 times, and it will use 8 times more memory, basically. But if I do this, then what will happen is when that configuration is bad, that child process will blow up, so the reason why this failed is because the container tried to rebuild itself and basically it couldn't. Probably we should catch that. If you call the constructor and there are any issues, then that should also, I guess if you want this to be robust, we probably just want to put it around here, to be honest. So when we call this, if there's any exception raised during the process of constructing the container, then the container was failed and we just retain the existing one. But what's useful about this is that exception, it will tell us, because Ruby has a pretty cool feature called caused by, or actually it's just caused, and if you write exception.cause, if you throw multiple exceptions, they will form a linked list of the exceptions, and so the top level exception you get, you can ask what caused this exception. So when the user gets this code, I guess down here, and it gets logged, async logger error knows how to log chained exceptions, and so it will print out a list. It will say the container failed because of a syntax error, undefined local variable, blah, 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 blah. So let's try that and see. I think this is probably, we want to be robust. The whole point of async container is to be robust. And so we would be silly not to at least consider handling that error. Okay, let's try that again. 51483 5143. Okay, so that worked, and now let's stuff up the config. Okay, so it tried to reload the container and it failed. I could not create the container because there was a name error, undefined local variable or method foobar, which is that, and that was caused by someone sending SIGHUP to the process. To me, that's really clear. You're really if I have one thing that really annoys me about software and software systems, is software that just silently eats exceptions or errors. It is the most annoying thing in the universe, because if you're going to debug any system, you need to know what's going wrong. And I think there's there's two sides. There's a line, and on one side you don't log very much, so that users feel comfortable. Oh, the system is operating correctly, even though maybe it's not. And on the other side, like, you probably end up logging like slightly too much at the, so that, but maybe something which is failing, well, from the context in which it's failing, yes, it's an error, but in the overall context of your application server, it's not actually impacting the health of your application server. Like, if your application crashes like once every 24 hours and it gets restarted, like, you can log that as an error. Like, it is an error, but it's not something which is really actually impacting the server's ability to handle requests. And so, when I designed and built async, coming from Celluloid, so I was building Ruby DNS and I was trying to figure out where to go next. And one of the things Celluloid would do is it would basically deadlock or fail with no errors or no output. There was this one method, or like there was this one way of debugging it where you could say, give me a backtrace of every running actor in the system. And it was just a nightmare to debug. So with async and the way the logging works, for me, it was just so important. I have had some people sort of complain, it's logging errors, but they're not really errors. Well, they are errors. They're just not errors which are impacting your application performance in a way which is really severe. It's a fine line, and you can be on either side of that. But I just the way I try and fit it together is I try and avoid swallowing exceptions. And again, like async container, its job is to be like super robust. So, I guess it's just the nature of it. And to be honest, like, we can add quite a lot of features for robustness in here, because you shouldn't be spawning thousands of processes per second. It should be like you spin up 8 processes and then the server chugs away for hours without any problems. So in that sense, I don't mind doing kind of expensive checks and balances in here, because the overhead, even if the overhead is high, the frequency is low. So what I want to do is I just want to confirm that this is actually still handling requests, because that's going to be the kicker. I've destroyed the config, and I have tried to restart the server. So there we go. So it's still running the old servers, even if I try and restart it. Now let's so let's try it. So I can restart it as much as I want, and it's not gonna replace the container with a new one because it couldn't load it. So that's actually not graceful restarting. That is rolling restart, but there's no grace period. The rolling restart is a way of spinning up the replacement application server and then transitioning from the previous instance of the application server to the new instance of the application with no downtime. And that's what this achieves. But the next step, and I guess this will probably be part 3, because I'm pretty sure I've been going for a while now. The next part will be tidying this up and actually implementing a grace period for shutting down, so that what is happening here is, if I do actually restart this, it was instantaneous. So if I'm running this and I reload it, oh wow, it actually just crashed. I don't know why it did that. But the point is, this request was terminated. And ideally, when you reload the configuration, you start up the new container, and the old container doesn't accept any new connections, but it stays around until all current connections have completed. And the difficulty in that is that if you have, like, say, WebSockets with persistent connections, or like this example here, which takes about 100 seconds to complete, then your grace period for the old container to stay around could be a long time. And I can imagine like there are scenarios in actual real applications where that could be a problem. Like if you have a database query or someone is even just downloading a file, like someone is downloading like a 4 gigabyte file, you know, the old container needs to sit around for quite a while. And, I don't know if there's again, like it's just one of these magic numbers which annoy me. I'm not quite sure what that should be by default. I mean, ideally, you think, okay, 10 seconds should be enough, but clearly it's not. Clearly there's like examples where that's not sufficient. So that will be part 3 of this, I think. How we work around that. And to be honest, like there's also more work involved in bringing the controller approach through to Falcon Virtual so that we can have graceful restarts of the virtual hosting, but that's even a little bit more complicated because this container, not only does the container have the application servers running by bundle exec, but it also, where is it? Not only do we spawn all the application servers into the container, we also spin up a hosts configuration and add that into the container. And hosts actually is handling, it binds to the secure and the insecure endpoints that you specify, pardon me. And then it runs a proxy which is doing the HTTP proxy through the application server, and it also runs a redirection which redirects HTTP to HTTPS. And so conceivably in here you could add or remove rack applications. So we can't just restart the application servers and add more or less application servers. We also have to restart where am I looking? Hosts. We also have to restart the hosts. Secure proxy, the proxy for normal web requests, and the redirection handler. So and the thing is, like, they only need to be restarted if an application server has been added or removed. So that's the interesting thing, because these only depend on the list of applications you're handling. And I think the end game for me is that when you run Falcon Virtual, it will install, it will monitor the file system for applications. And if you just upload an application into like your serve http /myapp, and you have a config.ru and a falcon.rb file in there, it will dynamically add or remove those applications as you like put them into that directory. That's kind of like, for me, like that's the end game. And then ideally, there's no need for you to explicitly restart the server when you change the configuration. Ideally, it's monitoring the config.ru file, like the modified time, or like doing a checksum, or both. And then if you git push or somehow or other install into that directory an updated configuration, then Falcon should just recognize that and restart like that part of the system. Like, to me, like, it should be fully transparent. Like, gluing all this stuff together with git post commit hooks and stuff just seems really stupid to me. Like, the server should handle all of that. So that's the end game. I'm not quite sure how many parts this will involve, but like, it could be exciting. Anyway, I think that is it for today. Thanks for watching. I hope it was interesting, and I will try and push all of this code so you can try it out yourself if you're interested. But there's a wee bit more work required here, especially with writing specs. So we'll see how we go with that. Excellent. Well, till next time.